Yes, class. Am I audible? Good evening.
Yes, ma'am.
Okay, so who all are present? Astha, Ahmed, Alan, Aryan, Mariam, Rehan, and Zaid. All right. So we had stopped at this formula. What was the name of this formula? Yes, this formula, lens maker formula. Yes, it is lens maker formula. So 1 by f is equal to n21. N21 is relative refractive index minus 1 multiplied by 1 by r1 minus 1 by r2. So r1 and r2 both are the radii of curvature. So we didn't do any numericals on this. Let's just quickly complete the numerical so that we could start lens formula. The derivation of lens formula was also left. No? So let us just start with the question. So note it down. See, outside medium is air whose refractive index is 1. Inside this is glass whose refractive index is 1.5. This is the radius of curvature 10 centimeter. Here the radius of curvature is 20 centimeters. Fine. So use the formula. See what is the focal length that you're getting. See, outside refractive index N1 is 1. Here N2 is given as 1.5. Right. And see, first radii of curvature here, this is positive plus 10 centimeters. And this will become, no, this is 10 is in front of the length. So this will be negative. And 20 centimeters is behind the length. So we'll take this as positive. So that becomes plus 20 centimeters. Now we just have to keep it in the formula. 1.5 by 1 minus 1. That will simply be 0.5 only. 1 by R1 minus 10 minus 1 by 20. This is what we'll get. Just solve it and see whatever your answer you're getting. One more question, let us see based on this. Okay, class, let's discuss this. See, this says that a convex lens of focal length 0.2 meter and is made of glass. So glass refractive index is given to you as 1.5. This is immersed in water. Water's refractive index is given 1.3. Now you have to find the change in focal length. So basically, what is happening? Initially, lens is there, and the outside medium is air. This is glass, right? So here, focal length in air, first let us calculate. So first, for air, it will be refractive index of glass with respect to air. So NGA, or you can write it as NG divided by NA minus 1, and simply 1 by R1 minus 1 by R2. Radii of curvatures are not given to you. Now see, so 1 by focal length in air, this will be 1.5 minus 1, 1 by R1 minus 1 by R2. Now see, this focal length in air is given to you. A convex lens of focal length 0.2 meters. So focal length of air is given. So let us keep the value, and from here we'll have the value of 1 by R1 minus 1 by R2. Understood? This is 1 by 20, 0.2, no? Focal length was 0.2. So 1 by 0.2 is equal to 0.5, 1 by R1 minus 1 by R2. Fine. So you can write 1 by R1 minus 1 by R2. This will be 0 up. So 10. Now see, second part of the question says, now this lens only, this is immersed in water. This is dipped into water. This is the lens. Now this is made up of glass and the surrounding medium is now water. So here there will be, the focal length will get changed because of medium. Because we have studied that it depends on refractive index, and for different values of refractive index, you'll have different values of focal length. Now calculate focal length in water. Do you see? Earlier it was glass air. Now the glass has been dipped into water. So medium is not now air. This is the medium, and this medium, this is water. So 1 by focal length in water, this will be refractive index of glass by refractive index of water, minus 1, 1 by R1 minus 1 by R2. Now, this time, this FW is not known, but we already know 1 by R1 minus 1 by R2 from this equation. We can keep this value here. So 1 by focal length in water can be calculated. This only was unknown, no, to calculate the change in focal length. So see, 1.5 is given by 1.3 minus 1 and multiplied by 10. Keep this entire value as it is. So now see, I hope you are understanding how to solve this now. So it will simply be this ratio of it, and we'll have the value of focal length. So this will be 0.17 if you take, right, if we take the LCM. So around 0.17 into 10 by 1.3. So that becomes 170 by 133, right? Let me take the reciprocal directly. So focal length in water will be 130 will be up now, divided by 170. So 13 by 17, this will be around 0. Then if we add, it will be 7, around 0.7 something, 7, 8 something. Just check the answer. Now change in focal length will be what? Focal length in water minus focal length in air. So that makes it 0.78 minus 0.2. So this will be 0.58 meters. How did we calculate it? Firstly, we calculated the focal length. Using the focal length formula, we found the value of the term 1 by R1 minus 1 by R2. Or we could have directly taken their ratio. Then 1 by R1 minus 1 by R2 would have got cancelled. So both the methods are right. Simply you have two equations, you have all the variables with you. Focal length of water is the aim to calculate, because how will we find the change? Focal length in air is already mentioned. Clear, class? Understood this question or not?
Yes, ma'am.
All right. Copy it down. If you have any doubts, let me know. Then some theoretical question I have to explain you. That we'll do. Some questions from theory part definitely comes in exam. That we'll discuss then. Now see, two types of theoretical question comes. Just a second. Yes, class. So see, two types of question come. One is based on if we cut the lens. Second is how to convert a diverging lens into converging, converging into diverging, those types. So firstly, let us see cutting of lens. Cutting of lens will come. You'll have to explain it properly. So lens can be cut in two planes. Lens can be cut in two planes. Let's say this is a lens that you have. So one is cutting the lens perpendicular to the principal axis. This is the principal axis. So if perpendicularly you'll cut, that will pass through the aperture only this way. So what will you obtain? See, let's say this was the initial lens. So initial lens will be having here R1 is there. Here R2 will be there, right? And here focal length will also be there. And we are taking identical, equiconvex lens we are taking. So radii of curvatures are equal. And this is the focal length, right? Now, see what will happen here. Let us first talk about this part only. If we calculate the lens maker formula and we apply the lens maker formula, calculate the focal length. This one, see, R1 that is present, this one will be negative and this one will be positive, right? According to the sign convention. So if you write this F, this will be N2 by N1. Let's say this is N2, this is N1. So N2 by N1 minus 1. And 1 by R minus R. So that makes it 1 by R plus R only. Directly I have written. So 1 by F is N2 by N1 minus 1. That is 2 by R. Now coming to the cut part of the lens. This is the normal part. This part you have studied. Now if I cut the lens, this will be each part that will be obtained. So this is the principal axis. C class, what will happen to this radius of curvature? This will become infinite because this is acting as a, what type of lens was this? In the last class, we had studied some names of the lens. Remember what type of lens was this lens? See, I have made
Plano-convex.
Plano-convex. Yes, correct. It is plano-convex lens. Because see, one side is plane mirror is present, no? So that plane mirror part, the plane mirror part that is present, that will give the look of a plano-convex, and bulge part is already there. So bulge part will automatically give the appearance of what? The convex lens. Fine. So concavity, convexity, see according to the lens class. Okay, whenever you're solving numericals also, because it becomes confusing sometimes. So according to the convexity, according to the concavity, cancel all these. Okay. Now coming to what we were studying, yes. So see, now this will become what? This will become infinity. So what change will come in the formula? See, even without writing, let's say about the new focal length. 1 by F. N2 minus N1 minus 1, this will be there. But 1 by R1 minus 1 by R2, which we write, this will become infinity. And 1 by infinity is 0. So 1 by F dash will simply, this be N2 by N1 minus 1. And this will be 1 by R. Now you have two equations. Take the ratio of them. This is one equation for the focal length of the complete lens. And this is the second equation for the focal length of the cut lens. The lens is cut now. So C, 1 by F is equal to N2 by N1 minus 1. Here 2 by R was there. Divided by 1 by F dash. N2 by N1 minus 1. 1 by R. This term gets cancelled. R gets cancelled. What are we left with? F dash is equal to 2F Means if your lens is cut perpendicularly to the principal axis, making the lens into two halves, right? And it's an equiconvex lens, then the new focal length will be double. So it can come to you to prove this. It can be asked also in 1 markers, the MCQs that you get. It can be asked in that also, what will happen to focal length, or proper 2 marks or 3 marks question can be asked from this. Fine. Now, if we cut the lens parallel, this was perpendicular. If we cut the lens parallel as in this is the principal axis and we are cutting it also like this. So you will obtain one part like this, other part will be obtained like this if you cut the lens. See here, focal length will not change. If this is F, these will remain the same. So focal length will not change. So just focus on what is the line of cutting along the principal axis, perpendicular to the principal axis. Note it down. One type of theory question, we'll see one more. Now see the questions that I was referring, second type of theory questions that come. So to identify, no, see, a convex lens is a converging lens, that is fixed. A concave lens is a diverging lens, fine. But this is a general case. That, and what type of case is this that we'll see. But see, it can also happen that a convex lens can also behave as a diverging lens. A convex lens can also behave as a plane mirror, plane surface, which you can say like a glass slab. Right. Same thing with concave lens. A concave lens can also behave as a converging lens, right? Apart from being as a diverging lens. But these are at certain conditions. So, first condition, now how to identify whether a lens is converging and diverging is not by just looking at the lens that it is convex, it will be converging. No. If it is convex, it can be diverging also if somehow you get the focal length negative. So what you have to focus on is focal length. If focal length is positive, then your lens is converging. If your focal length is negative, then your lens is diverging. Now see, this is the let's say N2 is greater than N1. It means the refractive index of the material of the lens is greater than the medium. I'm not saying this is glass. I'm not saying this is air right now. Just I'm referring to the medium 2, medium 1. All right. Now in this case, N2 is greater than N1. See, if N2 is greater than N1, no. N2 is greater than N1. So N2 by N1 will also be greater than 1. Come to lens maker formula. 1 by F is what? N2 by N1 minus 1. 1 by R. Okay, this is negative, this is positive. So this will again be 1 by R plus 1 by R1 plus 1 by R2. Now see class, this term is positive. Look here. This term N2 by N1, this is greater than 1. So tell me class, if this term is greater than 1 and you're subtracting 1 from this, so on subtracting 1 from this greater term, will we get this entire term as positive or negative according to you?
Positive.
Positive. Good, Rehan. Because this is something greater than 1. It can be 1.2 also. It can be 1.5 also. It can be 8 also. It can be 100 also. Any number that is greater than 1. So obviously if this is greater than 1, this term also will be positive. Positive multiplied by positive. Ultimately you will get the focal length as positive. What did I say? If the focal length is positive, lens behave as a converging lens. So if you're asked to complete the ray diagram, normally the way you draw the ray diagram, no, for a converging lens, draw it like this. That you can do later on. But now, coming to another case, if N1 is greater than N2, see here you will find the difference. N1 is greater than N2 means outside surrounding is greater than the refractive index of the lens. So N2 by N1 will be less than 1. Same thing, 1 by F, N2 by N1 minus 1, 1 by R1 plus 1 by R2. This term is still positive. But see, now this term is smaller than 1. Lesser than 1 term, you're subtracting it from 1. It's like you're subtracting 0.5 minus 1. So you'll always get minus 0.5. Right? 0.3 minus 1, minus 5 minus 1. All these numbers which are less than 1, 0 minus 1, any number that is less than 1. If you subtracting it, you will get this as negative. If this is negative, negative multiplied by positive, focal length will be negative. It means the lens behave as a diverging lens. So it means your convex lens only it will behave as a diverging lens. Means properly it will behave like this. But this is suitable for a specific condition. That specific condition is this is outside part, that is N1. This refractive index has to be greater than the glass. Why do we get convex lens as always? Converging lens is the fact that always we have glass, and usually whenever we have glass, the surrounding medium is lesser than the refractive index is lesser than whatever is the refractive index of glass. Usually glass's refractive index is quite high. You have seen 1.5. For air, it's 1. For water, is 1.3. Some materials have the refractive index greater than 1.5. If you keep the glass over there, you will notice that it is behaving as exactly as a concave lens. One last condition. If somehow we make it equal, n1 is equal to n2. So in this formula, if n1 becomes equal to n2, see, n2 by n1 minus 1, 1 by r1 plus 1 by r2 is here. This term is positive, but see, it's not about positive, negative. Do you notice here? N2 is equal to N1. This becomes 1. 1 minus 1, 0. So 1 by F is 0. And so F will be 1 by 0. And 1 by 0 is infinity. Focal and infinity. Plane mirror.
Plane mirror.
Yes, plane mirror. Now see, it would be like you have the lens, rays are coming, rays are going straight away. It's like we call this condition, no, in the exam sometimes the conceptual questions are asked using the term invisible lens, because even if I take out the lens from here, the rays will have this path only. By putting the lens, there is no difference that is occurring in the path of the rays. So you can get questions. The question basic thing, no, that the examiner wants to know from you will be this part only, but the modifications can be different. One simple will be show how a convex lens can behave as a plane mirror or a glass slab. More than a plane mirror, not even a plane mirror. It's better if we use the term glass slab, because no, plane mirror does the function of reflection and all. So mirror part, if we let's avoid it. Though I know you all have understood this concept of mirror part, but it's better if we write it as glass slab. Or this condition is known as invisible lens. So how can you make the lens invisible? If you keep the lens exactly in the same material, exactly in the same medium in which the lens is made up of, you will see there won't be effect in the path of light ray. So keeping the lens has no meaning. Right. So these conditions are asked, these three conditions in your theory part. All right. And these 2 points are very important for solving it. These 2 parts are very important. Note down these parts. Then one topic is left, that is lens formula. Now the derivation of length formula is not difficult. It is similar to what we have derived for the mirrors only. I have told you the formula when we were discussing lens maker formula, that yes, in one part 1 by v minus 1 by u got utilized, and that was simply the lens formula. Now see, in the derivation, no, what do? First step is take the object. One ray will pass through the optical center, which will retrace itself. One ray will go parallel to the principal axis and it will get refracted by the lens at a particular point when both the rays will be meeting, where both the rays will be intersecting. That particular point will give you the image. So A dash B dash becomes the image, right? Foci are given, focus we have taken. So this becomes the focal length. Now this part I have just taken O2, I have joined the line from the optical center to this point. Just this line OO2 is parallel to AB because every time using AB is difficult. So instead of using AB, if I use OO2 for certain triangles, because for derivation we have to make construction. So here I'm not constructing anything. It's just that I have joined this line from where the refraction was occurring and from to the optical center. Now the distance where object is kept is known as object distance. Image distance is marked from the optical center, and we have focal length. So we just have to establish relationship between these three. So look at this triangle, ABO, and this triangle, image A dash B dash O. Can you see both of these angles? These are vertically opposite angles, and the common side is this. Both have this common side, right? So it means both the triangles are similar. Same thing, we'll use similarity criteria only. So triangle ABO and triangle A dash B dash O, both are similar. So A dash B dash by AB is equal to OB dash by OB. Fine. Now look at this triangle, this one, O2OF, this one, O2OF. And look at this triangle, A dash B dash F. Same thing, vertically opposite angles, same side it is having. So that is making it as a similar. So triangle OO2F is similar to triangle A dash B dash F. Now again, A dash B dash by OO2 will be equal to FB dash by OF. Similarity triangle. Now see, OO2 can be written as, that's what I was saying. No? Now OO2 can be written as AB. So A dash B dash by OO2. No, A dash B dash by AB. Instead of OO2, no, I'm writing it as AB. So OO2, I'm writing it as AB. This is FB dash by O. So this was one equation, this was another equation. Both were having A dash B dash by AB common. So it means we can equate both these equations since they are having the same terms. Just remember the triangle. Just remember the names of triangle for the starting. If you have practiced, if you have studied for your exam, whenever you studied, so if you study it properly, then even if you just remember which triangles you have to take similar, no, then rest of the derivation you will be able to manage. So now OB dash by OB is equal to FB dash by O1F, right? Now see, FB dash has no physical meaning. Instead, this FB dash, see, FB dash has actually no meaning, no, this entire FB dash, this term, just this term. Even if it's from optical center, we would have taken it as image distance. But just FB dash has no meaning. So instead, we can write FB dash as what? We can write this FB dash complete OB dash minus OF. Do you see it? Complete OB dash this. Complete this minus this part OF. Complete OB dash minus OF will give you what? FB dash left only. Because FB dash has no meaning, we require some terms which has image distance, object distance, and focal length. Now all these terms have all these. Look here once. OB object distance. See here, OB is object distance, minus U we will take. OB dash, this is image distance, plus we will take. OF, O1F you can write, or OF you can write, this is focal length. Instead of writing O1F, I'll write OF only, because everywhere I have written it OF. So see, I was saying OB is minus U, OF is focal length, and OB dash is image distance. So now keep it in this. So this will be V by minus U is equal to V minus F by F, because in the denominator you had OF, so F. So minus V by U is equal to V minus F by F. This we have, let us cross multiply. So we get minus VF is equal to UV minus UF, right? UV minus UF. Please correct me if I have written something wrong. Minus VF, yes, it's fine. So now let's bring the terms that have F common. So that becomes minus VF plus UF. This is equal to UV. Now let us divide this entire equation by UVF. Divide by UVF. So you have UF minus VF is equal to UV. We are dividing it by UVF, divided by UVF, divided by UVF. So from here, UF gets cancelled, VF gets cancelled, UV gets cancelled. We have got our answer. 1 by F is 1 by V minus 1 by U. Use proper sign conventions. Just at one place, optical instruments, you don't have to use sign convention. Rest everywhere in ray optics, sign convention is important. Coming to magnification, magnification will be continuation of this only. See, from the triangle, no, we could write magnification as, okay, apart from this, magnification is what? Magnification is height of image by height of object. So height of image is A dash B dash. A dash B dash only was the height of image, no, like this. And height of object was AB. So at one place, remember, we wrote it as OB dash by OB. A dash B dash by AB is equal to OB dash by OB. That makes it V by minus U. So magnification's formula for lens. See, for lens this becomes, and this is height of image by height of object. So magnification, if you equate height of image by height of object as this, see, height of image also we'll take it as negative, because image is formed beneath the principal axis. So here we have this negative sign, and again minus V by U. This negative gets cancelled. Ultimate formula will be height of image by height of object is equal to plus V by U. In mirrors, you are getting minus V by U. This is plus V. All right. Yes, class. Understood the derivation or not? Any difficulty at any step? Clear? To others as well, or only to Zeds? Here, Jiva, Alan, Ahmed, Mariam.
Yes, ma'am. It's clear.
Okay. Okay, note it down. Just at any step, if you get stuck, you're not able to understand, just ask me. I'm here only. Now see class, same way the way we had magnifications, conclusions. Using magnification, we could calculate the image, whether it is real inverted, whether it is virtual erect, right? Or you can say magnification size can also be predicted. Like see, if magnification's magnitude, right? Magnification's magnitude is there. So if it is greater than 1, then your image will be enlarged image. Then, and when it is less than 1, image will be diminished. And when the magnitude will be exactly 1, whether plus or negative, that is not our concern. If it's just 1, then image will be of same size. And when we take the magnification, if the magnification is negative, let's say -5, so negative magnification, that will give you real and inverted image, and positive will give you virtual and erect. So this conclusion we had already written, all of you have it. Now note it down again. Same thing is for the lens. Then one numerical is there. This is question from your NCERT only, that we'll discuss it. First note it down this part, then we'll. Anushka, after the class, no, do take this recording. Okay.
Yes,
All
ma'am.
right. And so that you can just see whatever parts you have missed, because now half an hour only is left. So though we have a topic, you will be able to understand it. But just do take the recording.
Yes, ma'am.
Okay, Razan. Okay, no issues. Now, see, combination of lens are given to you. One is a convex lens, then is a concave lens, last one is a convex lens again. Focal length of all these three lenses are given, plus 10, minus 10, plus 30, right? Plus 10, minus 10, plus 30. And first object distance from the convex lens is given as 30 centimeters. Then from the lens to the concave lens, both the lens have the separation 5 centimeters. And separation from both the lens will be 10 centimeters. This is given in the question. You have to find out separation of final image, position of final image. Now see, just focus on lens 1 right now. So for lens 1, object distance is minus 30 centimeter. Focal length is plus 10 centimeters. Image distance for first one is not known. Let us calculate that. So this will be 1 by f1 is equal to 1 by v1 minus 1 by u1. So 1 by 10 is equal to 1 by v1 minus 1 by minus 30. So this will be 1 by v1. So 30 then by 2, that will be 15. So v1 will be plus 15 centimeters. All right, this is plus 15 centimeters. So it means this will get refracted, but it will again get refracted because of the second lens. This is second lens. This will also refract this ray. But let us see, that we'll see when we'll come to second lens. Let's see if this was not to be refracted, where it will lie. See, 15 centimeters will be where? From the optical center of this. This is 5 centimeters. This is 10 centimeters. So exactly this distance is only 15 centimeters. It means this will be formed exactly at the optical center of the third one. Do you understand why I drawn this? Because this entire separation is 15 centimeter, and by my calculation also I'm getting 15 centimeters. So it will be behind the lens. This will be 15 centimeters. So this is located. Now see, can you remember one thing? Remember we did this type of object and then images. Now this intermediate image that is formed here, this will act as the virtual object for the second lens. Remember I told you when we use combination of lens, then you get the concept of virtual lens better. Now consider lens 2. For lens 2, object distance is this 10 centimeters. Understood? This plus 10 centimeters becomes the object distance. And see, remember I told you for virtual object, you get positive value. So see, you are getting positive value for virtual object. You can get negative also. That is not fixed, but here we are getting. So that's what I'm discussing. And focal length is minus 10. So minus 10 focal length. See, this question's calculations are not very lengthy though. This is simple lens law, not lens law, lens formula. Fine. And then U2 This will be plus 10 centimeter. Focal length is minus 10 centimeter. Let's find out final image for this one. So see, again use minus f2 is equal to 1 by v2 minus 1 by u2. So 1 by v2 will be 1 by f2 plus 1 by u2. Here if you keep the value, 1 by v2 will be 1 by minus 10 plus 1 by 10. This becomes 0. So 1 by v2 is 0. It means v2 is formed at infinity. This is second. First image was formed at 15 centimeters. Second image is formed at infinity. It means now completed. For the second lens, final image is formed at infinity. It will form at infinity if this third lens was not to be present. But see, for the third lens, you don't need to even make calculations. Can anyone answer? See, for infinity, from the second lens, these rays are going parallel. But because of the obstruction of the third lens, it will not be, the final image will not be at infinity. Fine, this is clear. But see, where will the final image be if these rays are parallel to principal axis coming from the second lens? Where the image will form? Rays are parallel to principal axis.
Ma'am, at the focus, right?
At the focus. Perfect, Anushka. At the focus. So it means the final image, this will be formed. This will be formed at a separation of 30 centimeters. It will converge. This will be exactly at a separation of 30 centimeters. So V3 will be 30 centimeters. Now in your questions, whatever question is asked, you can answer this if you have all the values. Because this depends on the question. It can ask you calculate the separation of final image from the first lens. So take all these lens 30 plus 10 plus 5, right? Calculate the separation of final image from the object. So this entire separation, 30 plus 10 plus 5 plus 30 becomes it. Calculate the separation from this third lens, separation between this and that. This you can manage if you have all the data. Fine, note down this question. Okay, class. So now optical instruments is one of the portion that is left. At least let's have an overview first of it, then we'll start with one of it. Now, optical instruments basically the use of mirrors, lens, prisms, all these devices. Prisms is left to be discussed, that we'll do after optical instruments. Fine, prism we have to do it. All right, mirror, lens we have covered. So these are basically used to extend range of vision. Now, what is meant by this statement? No, that I have written. This is simply that C class. For all these parts, for any image that you see, at a certain image only will be seen. No, even though if you use specs, let's say spectacles that we wear, it enhances the image, but at a certain, for example, I want to see Jupiter, and I'm present on Earth right now. So how will I be able to see? Right. So telescope will help me because it will extend my range of vision. My range of vision is human eye has a certain range of vision. So to expand it, to see something beyond it, and something, let's say, very microscopically is present, very, very tiny, very fine particle is present. So my range of vision is not that much. I'm able to see just gross objects. What about the fine objects then? Right? The way in biology, cells, structures, and all these are observed. They are observed using microscope only because it extends the range of vision. So what you have in your syllabus, you have microscopes. In microscopes also you have simple microscopes, you have compound microscopes, then you have telescopes. So telescopes is not difficult. All this topic, see, in this, no, just understand the first one, this one, simple microscope wala samajh lo, then rest of the things are just based on this. Then you'll see, no, monotonous it is becoming. Even I will just be editing the same diagram only. That's how it comes, right? And see, regarding this eye, human eye that is present, this is, you will find this is in NCERT. And if you look very old previous years papers, no, of that have arisen in your board exams, fine. If you look it at, you will see how questions are available on eye. But do not be confused. Human eye has been deleted a long time back, and for your syllabus, especially, eye is definitely not there. But earlier, you in NCERT find diseases are also present: hypermetropia, myopia, all these diseases. No need to study any of these. Fine. Human eye has a basic structure, which all of you know. Convex lens is present. Then an outer layer is present that is known as cornea. Scleroid layer is there. Choroid membrane is there. All the three layers, outermost protective coverings of the eye. Between the lens, and this lens is held through the help of ciliary muscles. And iris is also present, which provides the color. Whatever color is of the iris, that will be the color of your eye. Then this separation between the cornea outermost layer and the lens is known as aqueous chamber, where aqueous humor is fluid present. Humor we use in biology whenever we have to refer to fluids. Humor term. You will notice those who have, they must have studied. And then at the back, there's a screen, which we say known as retina, where the final image is formed. Right. So this space between convex lens and between the lens and the retina, this is known as vitreous chamber, where vitreous fluid is present. And then, you must have heard of rods and cones. They are also present within this retina space. So point is there where no cones are present. You call it as blind spot also. Behind that blind spot, you have an outlet for the optic nerve. So optic nerve takes the image, this nerve takes the image, whatever, because here no inverted image is formed at the retina. And then this takes it to the cerebral cortex area of the brain, wherever the visual cortex area is present in your brain. And the brain then detects and other neurological functions occur. So this is a very small overview, which you all should know. Otherwise, no need to go into the details. Those students who have biology will study it. In physics, no need to even study this. No need to even revise it for your exam. What you have to revise is, firstly, we'll start with simple microscope. But before that, no, you will notice for every instrument, simple microscope, compound microscope, telescope, all these three, we'll be using near point. Then we'll see when image is formed at far point. First image formed at near point, then image formed at far point, right? We will see all these things. Now, yes, Anushka.
Ma'am, there's this traveling microscope as well, right?
Traveling microscope, yes, traveling microscope is also present. See, when I say no, microscopes are of two types, simple and compound. That is the very basic classification of it. Apart from traveling microscope, also no more types of microscopes are present. Electron microscopes, so many microscopes are present. Especially when you go to the research field, various types of microscopes you are present with slight modification. So what is present in your syllabus is has it's like it's not been refreshed or what, or to make it compact, or just to have a basic knowledge, only this part is present, simple microscope and compound. But in reality, if you actually go to through whatever devices are present, microscopes are numerous types. They are not just simple and compound. Various lenses are there for now, though many microscopes are present, different types of microscope. But yes, for your basic knowledge for class till class 12, simple and compound microscope is there. So it's not just only traveling microscope. Very ultra electronic microscopes are also there. Different types of microscopes are also present. Fine. Even for telescope also, not only astronomical telescope, reflecting telescopes are there, Cassegrain telescopes are there, various telescopes are also there. So regarding devices are numerous. It's just that because of the syllabus restriction, we have just two focused it. Now, near point means what? Near point means at a distance till the maximum nearest distance from the eye to which we are able to observe the thing clearly. Like all of you can do this activity. Bring your pen with which you are writing very close to your eye, parallel, just touching the tip of nose, and look at it. You will see it as blur. You're not able to see it. Sometimes you will see two pens. You will be able to look at the same pen, but when you will shift it, bring it away from your body, move it away from your body. When you move it away, you will see still it is blur, intensity is low, but two images are formed which are getting combined. At a point will come where you will see, yes, you'll be able to notice a clear image formed near to your eye only. That is known as near point. So closest distance of object from eye and near point for humans, this is minimum is 25 centimeters. So this distance, though, this is also known as least distance of distinct vision. Usually we'll denote it by capital D, least distance of distinct vision. So one case you will see where your final image is formed at least distance of distinct vision. One case you will see is far point. Now far point means till what distance you can see. I'm able to see the screen of my laptop. So that is not my far point. I can see the things that are present, like a wall that is present, the wall of the room. I'm able to see that also. If you go out, you are able to observe the moon also. You are able to see the sun also. Are the sun and moon located at just 25 centimeters or what? No, because human eyes far point is infinity. It's infinity. If you clear off everything, and the solar system was not constructed in this manner, and if it was in a straight line, everything that could be observed, you could directly from your naked eye see all the planets that are present. Obviously, size will be smaller. Size will be smaller. Angle parallax will exist, but you will be able to see it. But yes, definitely, because the construction is different, everything is different. This is not possible. But just take the example of sun. Sun, you are able to see. So sun, moon, all these things are visible. Why? Because far point for human eye is infinite. Fine. Note down these introductory points. Those who have completed, you all can stay. Anushka, just wait after the class. Rest
Yes,
of you, those who have completed, you all can leave. We'll complete this tomorrow. Optical instruments will be completed tomorrow.